Welcome to Shifting Grades. I'll be doing a mathematics lesson. In the former lesson, we introduced the topic sequences and series. And we started by seeing what sequences are. We said when numbers are arranged in a regular manner following a certain rule, they form what we call a sequence. Then we went ahead to state two types of sequences, whereby we saw the arithmetic sequence, the AP, arithmetic progression, whereby we say these are a type of a sequence whereby the pattern or the regular pattern obeyed in this type of a sequence is such that from a term to the next there is a common difference added. Therefore, we say to get the nth term in such a sequence, we take the first term and we add n minus 1 multiplied by d, where d is the common difference from one term to the other. The second type of sequences we said is the geometric sequences, BP, geometric progression, whereby we say now in this case from a term to the other you find that there is a certain scalar multiplier, and that common multiplier in all cases we call it the common ratio, whereby we said now to get the nth term in a geometric progression, then we have to take the first term times r raised to n minus 1. So that's what we said yesterday or in the former lesson. In this case now, we will be checking what series have. That's why I've written now number 2, because we did away with the sequences. Now we'll be looking what series have, and we say when the terms in a sequence are added, then a series is obtained. A series is obtained. A series is obtained. Therefore, a series is when from the first term to a given last term, when they are added, then we say that is a series now. So we say now instead of having 2, 4, 6, 8, 10, they continue like that. We say now 2 plus 4 plus 6 plus 8 plus 10. Continued like that. Therefore, this is a sequence, as we said yesterday. This one now is a series. When the in a given sequence are added up, we obtain a series. So definitely, because the sequences we have arithmetic and geometric, then it means when the terms in an arithmetic progression are added, we obtain an arithmetic series. Therefore, the terms in arithmetic progression added, we get arithmetic series. Similarly, when terms in a geometric progression are added, we obtain a geometric series. Therefore, the type of a series depends on the type of the sequence. Whose terms are being added. Whose terms are being added. We can examine now this case. Consider the sequence or the series, sorry. Can have it as a series. Consider the series 2 plus 4 plus 6 plus 8 plus 10. Just the one I've given an example here. When we add all this, we get 2 plus 4, 6, plus 6, 12, plus 8, 20, plus 10, 30. Therefore, when they are added, we get 30. Now, check now this generalization. Generally, to obtain the sum of n terms in a series, then we say that the sum of n terms is given by, when we take n, divide by 2 into 2 multiplied by a plus n minus 1 multiplied by d. We can also use another formula. The sum of n terms is equals to n divided by 2 into a plus l, where l is the last term. L is the last term and A the first term as usual. N the number of terms. We can now check these two formulas for the case we have taken. So in the above example, A is equals to 2. Then the common difference is equals to, I think 2 again, because from 2 to 4 we have added 2. 4 to 6 we've added 2. So the common difference is 2. So you can now check the number of terms. N is the number of terms. Therefore, the number of terms in this case is 1, 2, 3, 4, 5. The number of terms is 5 in this case. Therefore, you can now say the sum of 5 terms will be n, 5, divided by 2 into 2 times 2, which is a, plus n minus 1 multiplied by 2, which is our d. Therefore, in this case, we shall obtain 5 divided by 2 into 4 plus 4 by 2 is 8. Therefore, this will be 5 over 2 multiplied by 12. So 5 by 6, we get 30. We got after adding in the long method. Just the same formula we got after adding in the long method. We can check the second method and say alternatively, we are saying that the sum of n terms is given by n over 2 into a plus l, where n is the number of terms, a the first term, l the last term. Therefore, n is 5 into a is 2 and l is the last term in that series, which is 10. Therefore, 5 over 2 by 12. This means by 2, 1 by 2, 6. 5 by 6, we get 30. Therefore, the two formulas, number 2 and this number 1, they are applicable to get the sum of a given number of terms in arithmetic series. So we can take another example now. Then take an example. we are told series. Example, in the series 1 plus 4 plus 7 plus 10 plus, they continue. Find the sum of the first. Find the sum of the first 15 terms. Find the sum of the first 15 terms. Solution. Because we have known that they were 4, 7, 10. These are 1, 2, 3, 4 terms. Because we can check that from 1 to 4 we have added 3, from 4 to 7 we've added 3, and from 7 to 10 we are adding 3. We can say that. So we can add 3 to 10 to get 13, add 13 to 3 to get the next term, and such and that until we obtain the first 15 terms. But that will be a bit tiresome. Instead of all that, getting all the terms and we add them manually, we can just go to this. Can go to that formula and say, in this case we've said the d is 3 and the first term is 1. Therefore the sum of n terms, we say it's given by n over 2 into 2 by a plus n minus 1 multiplied by d. So the sum of the first 15 terms will be 15 all over 2 into 2 times 1 plus 15 minus 1 d, which is 3. Therefore this will be 15 divided by 2 into 2 plus, this will be 14 by 3, 42. Therefore this will be 44 22 by 15. So we will have 22 multiplied by 15, which is 330. 330. I said the formula is a 2. We have also this method which says that the sum of n terms can be obtained by n over 2 into a plus l, where l is the last term. Therefore, if the first term is 1, we can check the last term, which will be the 15th term. And from the previous lesson, we know how to get the nth term. The nth term in an AP. Because nth term is gotten by a plus n minus 1 into d, then 15th term can be obtained by a, which is 1, plus 15 minus 1 into 3. Therefore this will be 1 plus 14 by 3, 42, which will be 43. Therefore in this case, the 15th term will be 43. Therefore we can say sum of 15 terms now will be 15 over 2 into, according to this formula, n over 2 into a, the first term, plus the last term, 43. Therefore we shall have 15 divided by 2, 4, and it will land us to the same value, 330. So we can use the two formulas interchangeably. Any constant, any constant. So that's how we obtain the nth term in geometric, in a arithmetic series. So we can check something on the geometric series now. On the geometric series. geometric sequence. Therefore, geometric series, part 2, geometric series is obtained when the terms in a geometric progression are added. Therefore, a case whereby it is a geometric progression and the terms are added, we get a geometric series. For example, when we have 1, 2, 4, 8, 16, 32, and such, and such. Find this is a geometric series because they are terms in a GP, which are from 1 to get 2, we've multiplied by 2, from 2 to get 4, multiplied by 2, from 4 to get 8, multiplied by 2, 8 to get 16, multiplied by 2, and such. Therefore, you find, now because they are terms in a geometric progression, whereby there is a common ratio, there is a common ratio, which is 2, and the first term, which is 1. We can first of all check the sum of these terms. 1 plus 3, 1 plus 2, which is 3, plus 4, 7, plus 8, 15, 15 plus 16, 31, 31 plus 33, we get 63. There are terms which are 1, 2, 3, 4, 5, 6. So in this series, the sum of the first 6 terms is 63. So we can consider this formula that the sum of n terms is given by a into r power n, then we subtract 1 and we divide by r minus 1. We can check this formula where a is the first term and we got r as the common ratio in that series. Then we have n as the number of terms, n is the number of terms. Therefore, having the first term as 1 and r as 2 raised to the number of terms, which is the first 6 terms in this case, then we divide by r minus 1. So this would be 1 multiplied by 2 raised to 6 is 64 minus 1. Then we divide by 2 minus 1. This will give us 1 multiplied by 63, and we are divided by a 1 here because 2 minus 1 is 1. Therefore, we will get 63 as the answer. Getting 63 is giving us the same value as we got after adding them manually. This makes us conclude that the sum of n terms in a geometric series Sn is given by a into r raised to minus 1 divided by r minus 1. This is when or where r, the common ratio, is greater than 1. When the common ratio is greater than 1, or the sum of n terms is equal to a into 1 minus r raised to n divided by 1 minus r, and this is when where r is less than 1. Therefore, the r can be a negative or the r can be a fraction, which means that now this should be a decreasing GP, whereby from one term to the other you are multiplying with a ratio less than 1. So we use these two formulas. This one when r is greater than 1, and this one when r is less than 1. You can check an example for each case. Find the sum of the first 9 terms in the GP. Find the sum of the first 9 terms. Now an example. Find the sum of the first 9 terms in the GP. The GP whereby we have 8, 24, 72. 8 plus 24 plus 72. Sum of the first solution. I said earlier on, because we know how to get any of the term, we can multiply this one, because you can say from 8 to 24 we multiplied by 3, 24 to 72 we've multiplied by 3. Therefore this means that because the first term is 8, here the common ratio is 3. We are multiplying with 3 to get the next term. Therefore I said because we've known that the sequence is multiplied by 3, we can multiply by 3 to get the next term until we get the 9 terms and we add them. But now instead of that, we got a formula whereby we are saying the first of 8 terms, and in this case r is greater than 1, into r raised to n, then we subtract 1, or divide by r minus 1. Therefore the first 9 terms, a is 8 into r raised to 9 minus 1 all over r minus 1. Therefore this will be 8 into 3 raised to 9, which is 19,683. Then minus 1, we get 19,682 divided by 3 minus 1, which is 2. Therefore by 2, 1 by 2, 4. Multiply this by 4, which will give us 78, 728 as the answer. Therefore that's how we get the sum of n terms. Find the sum of the first terms. Excuse me. Find the sum of the first 10 terms in the GP. Find the sum of the first 10 terms in the GP. 8. First one is 8. Second one is negative 4. The next one is a 2. Then they continue like that. Solution. We can see the first term is 8 in this case. So we can get the common ratio. We can check what has been multiplied in each case to get the next term. So in this case, we got negative 4 divided by 8, so that we may know what has been multiplied, or we take 2 divided by negative 4 to see whether the answer will be the same. And in each case, we are getting by 4, 1, by 4, 2, negative half, by 2, 1, by 2, 2. So negative half is the factor multiplying those terms, so that we may get the next term. Because from here to here, negative half has been multiplied. From negative 4 to get 2, negative half has been the multiplier. Therefore, Now we can say the ratio is negative half. So in this case now, because r is less than 1, we use the formula a into 1 minus r raised to n divided by 1 minus r. Therefore, when we take the first term and 1 minus the common ratio, we've said it's negative half, and we raise it to 10 because we are dealing with the first 10 terms, all divided by 1 minus half. 1 minus half. Therefore, the sum of the first 10 terms will be 8 into half raised to 10 is 9.765 by 10 power negative 4. Therefore, we can subtract 8. We can have 8 minus, which will be 7.99. Then we divide by, when we take 1 minus half, it becomes 1 plus half. So this should be 1.5. Therefore, this divided by 1.5 will give us 5.333, not recurring, 333 to 4 significant figures. Therefore, the first 10 terms in that series will give us 5.33 like that. So that's how we get the sum of a given number in a given series, whether geometric. We use this formula when r is greater than 1, and we use this formula when r is less than 1. So that's how we operate them. I'll be bringing another lesson whereby I'll give now some more complicated cases whereby there will be the concepts of getting any term, the sum of terms, geometric and arithmetic, all combined together in one question, and we will see how to go about them. So thank you very much for following. Kindly subscribe to Shifting Grades.